Hello everyone and welcome to Python Scientific Computing Tutorials. In this tutorial, we explain how to define matrices and how to perform basic matrix operations in Python by using the NumPy library. Also, we explain how to save matrices to files and how to load them in the Python memory workspace. But before I start with the explanations, I would like to mention the following. It took me a significant amount of time, energy and planning to create this completely free video tutorial, as well as almost 400 free video tutorials that you can find on my YouTube channel. Consequently, I kindly ask you to press the like and subscribe buttons. Also, if you have a question or a comment about the material presented in this lecture, please feel free to ask your question in the comment section below. Thanks. Okay, let's start. The first step is to import the NumPy library. We do that by typing import NumPy as np. np is the standard name for the NumPy library. First, let's learn how to define matrices by using NumPy. Let's define a 2 by 2 matrix that looks like this. A is equal to 1, 2, 3, and 4. We define this matrix row-wise. That is, we type A is equal to np.array. And over here we specify the matrix. These two symbols represent these brackets of the matrix. Then, let's define the first row. The first row is 1, 2. Consequently, over here we will type 1, 2. Then, we start with the next row by adding comma over here, and then we specify the second row, 3, 4. Okay, so let's see the result. Here it is. Here is our matrix A. Perfect. In this video, we will need two more matrices, so let's define them. Here's our matrix B, again, 2 by 2 matrix. The first row is 5, 6. Then the second row is 7, 8. Let's see this matrix. Here it is. Next, let's define 3 by 3 matrix, C. And the C matrix will look like this. It will be 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's type this matrix. C is equal np.array. And let's specify the matrix. First row is 1, 2, 3. Second row is 4, 5, 6. And the third row is 7, 8, 9. Here's our C matrix. Perfect. Next, let's type whose. Okay, we can see three matrices, A, B, and C, and we can see that they're of type integer 32. That is, the entries are integers. We can verify that by typing, for example, c.dtype. And we can see that the entries are integers. However, sometimes we would like to specifically define matrices of certain type. Let's define matrices of doubles. Let's define a G matrix, which will be 2 by 3 matrix, and it's equal to np.array. And let's specify the matrix. It will be 1, 2, 3 in the first row. The second row will be 4, 5, 7. And over here, I will type comma, and I will type np.double. Let's see the result. And G, here it is. We can see dots here. This is very important to observe. If you, for example, see C doesn't have dots, however here we have dots. This means that this matrix actually consists of doubles. And we can verify that by typing GD type. And we can actually see that this matrix is of type float. You can also see that by typing whos. Perfect. Next, let's learn how to define zero and identity matrix. Zero matrix is defined like this. np.zeros, and over here we specify the shape. So I will type shape is equal to 4 by 4. And let's see this matrix. Here is Z4. Perfect. The identity matrix is defined like this. I will define a 4 by 4 identity matrix. I will type np.identity and I will specify dimensions. Here it is. I4. Perfect. Another approach for defining the identity matrix is to use I. This is a very similar function to MATLAB's I. Let's define a 3 by 3 identity matrix. We type np.I, and here it is. I just need to change this part over here, and let's see. Here it is. Perfect. Next, let's learn how to access rows, columns, and block matrices using a very simple notation. This notation is very similar to MATLAB's notation. For example, let's look at the C matrix. Here it is. In Python, indices starts from 0, 0. That is, if we want to access the element 1, 1, we will type 0, 0. And here it is. Then we can change this element. For example, we can assign 5 over here. And let's see the output. Here it is. The first element is 5. Let's return the first element to 1. Okay, this is our C matrix. Let's access the first row of the matrix C. We do that by typing 0. Since 0, that is the first index, is the index of the row. And we type comma. And over here, I can type something like this. This will give me all the entries on the 0th row. And let's see the output. Here it is. Obviously 1, 2, 3. Let's access all the entries on the 3rd row. We do that by typing 2 and this symbol. And here it is. 7, 8, 9. Perfect. Let's now retrieve the second column. Consequently, we need to type C, then all rows, that is, entries belonging to all rows, and over here we just need to specify the index of the column. Since we want to access the second column, we will have to write here 1. And here's the output. So it's 2, 5, 8. And here is the output. Now, let's learn how to access matrix blocks. For example, let's say that we want to retrieve this block of the matrix. So how to do that? Relatively straightforward. We will just type the following. C, then obviously we want to retrieve the rows 0 and 1 and the column 0 and 1. So we will write 0 until 2. However, we don't include 2. So when we write something 0 until something, it is that something minus 1. Here we are actually retrieving the rows 0 and 1. Then we will type for columns 0 until 2 minus 1, that is 0 and 1. So let's see the output. Here it is, 1, 2, 4, 5. Now, let's retrieve the block given over here. How to do that? Well, it's straightforward. Again, using the same logic, let's count. The rows are 1 and 2. And we have to be very careful over here, since we cannot define the end so easily, so we need to type something like this. 1 until, just leave it like this, and 1 until, just leave it like this. And let's see the output. Okay, here it is. 5, 6, 8, 9. 5, 6, 8, 9. Watch out here. If we typed, for example, 2 over here and 2 over here, we will only retrieve the central element, that is 5. And here it is, so be careful. Here's another approach for retrieving this block. We can do it like this. Minus 2 and minus 2. And here it is. Perfect. Now let's learn how to get the number of rows and columns of a matrix. We do that by typing a dot shape. Here it is. 2 by 2. Let's see whose. What do we have in our memory space? Let's see our matrix G. Here it is. We can type G dot shape. And obviously it's 2 by 3 matrix. Then we can directly get the number of rows by typing a dot shape 0. And as the result we will get 2. Similarly, for the G matrix, we can type G shape 0 to get the number of rows, and we can type G shape 1 to get the number of columns. Next, let's learn how to transpose matrices. Here's our G matrix. To transpose this matrix, we will simply type G dot T. And this will give us the transpose. We can also type G dot transpose. And let's see the output. Here it is. Let's now add two matrices. This is our matrix A, this is our matrix B, and let's type S is A plus B. Here it is. Here's S. It's obviously 6, 8, 10, and 12. Now, let's multiply a matrix by scalar. Let's see the result. For example, if I type 2 times A, let's see the output. And obviously, we are multiplying every element by 2. Okay, let's learn how to multiply two matrices. That is, how to multiply a matrix by a matrix. How to do that? A naive approach would be to simply write A times B. Let's see what happens here. Here's A times B. Let's see A, and let's see B. Again, let me just do this. Here's A, here's B, and here's A times B. Something is not correct over here. So let's verify it by using our hand. That is, let's do it manually. Let's just verify one element. 1, 2, 3, and 4. And over here I have 5, 6, 7, 8. Now, this element over here should be 1 times 5 plus 2 times 7. So it should be 5 plus 2 times 7 is 14. So 5 plus 14 gives me 19. And over here I can see 5. So something is not good over here. So what actually happened over here? Well, This operator, star operator, actually multiplies two matrices element-wise. And you can see that 1 times 5 gives you 5. 2 times 6 gives you 12. 3 times 7 gives you 21. And 4 times 8 gives you 32. So this is not matrix multiplication. Be careful. In MATLAB it is, in Python it's not. There are several ways to multiply two matrices in Python. Here's the first approach. We can type A, then we can type dot, and then we can type B. And let's see the result. Here it is. Obviously, it's 19, 22, 43, and 50. This is the first way. The second way, let's type, for example, this S1, so we can keep track of everything. The second way is to do this. We can use NumPy.mat multiply. Short is mat mul. And let's specify the matrix. We specify A and we specify B. And let's see the result. Okay, and let's get our S1. So let's double check everything. This is S1 and this is S2. Perfect. And there is a third way for multiplying matrices. The third approach for multiplying matrices is to use the add symbol. So we type A and then add B. And let's see the result. Here's the result. S3. Perfect. Next, let's learn how to define block matrices. I will construct a block matrix that looks like this. This block will be equal to A, this block will be equal to B. Then over here, I will have another matrix that will have 4 columns and 2 rows. Consequently, my block matrix will have 4 rows and 4 columns. Let this matrix, that is, the last block row, be denoted by X. Let's first define X matrix. So let's type X is NP array, and we need to define this matrix row-wise. Consequently, we need to specify the blocks. Here, the block is -1, -2, -3, for example, -4. Over here, we have 10, 20, 30, and 40. So this is the block X. And let's just erase this part so we can see it better. Here's the X block. And let's construct our block matrix. Again, I will write the block matrix here in the corner. The block matrix should look like this. A, B, and over here we will have X. Let's do that. It's relatively straightforward. I will call the matrix block matrix. And then I will type NP, the function is block. And then again, we specify the matrix. Let's type something like this. Now we specify block rows. Over here I will have A, comma B, and over here I will simply have X. Let's see our block matrix. And let's see the block matrix. Here it is. Perfect. A, B, and the block X. Next, let's learn how to invert matrices. Let us invert the matrix A. To do that, we need to use np.linealgebra.inverse. And then we just specify the matrix name A, and let's define A1. So let's see the result. Here it is. This is A1. How to verify that this is actually an inverse matrix? There are two approaches to do that. We can, for example, multiply A1 by A. So we can type A1 at A, and let's see the result. Here it is. We can obviously see that this is the identity matrix. Don't be confused by this part over here. This is effectively 0. Next, let's learn how to save a matrix to a file and how to load a matrix from a file. To save a matrix to a file, we will use the function save. And over here, we will specify the name of the file. Let's call it matrix file. And let's specify the extension. The extension is NPY. And over here, we specify the name of the matrix that we want to save. For example, we want to save the matrix G. Now, stop here for a second and look at your active folder. If you're using the spider as I'm using, the active folder, that is the current folder, is given over here. You can also type something like this, ls, to see the content of that folder. So here I am. Okay, let me save this matrix. And let me again look at the content of the folder. Here it is. Here's my matrix. Before saving this matrix, everything was empty. Okay, now let's load this matrix to our workspace. I will call a new matrix G4. To load the matrix, I will type np.load, and I will specify the name of the file. Here it is, and let's see. Okay, so here's G4. Now let's compare the two matrices. Let's type something like this, print G, and then let's do this Boolean operator, G4. Let's see what will happen. Okay, we can see true, 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 true. This means that the matrix G is actually equal to G4. That is, all the elements of G are equal to the elements of G4. That is, saving and loading the same matrix works perfectly. Okay, that would be all for today. I hope that you liked this video. If you like the videos I'm creating, please press the like and subscribe buttons. Thanks a lot and have a nice day.